A country's power grid, its water supply, and its telecommunications networks. For decades, these physical systems defined national security. Now, as generative AI drives the mechanics of modern society, the capacity to process data has become the foundational pillar of a state's resilience. If a state relies entirely on foreign-owned computing power for its critical workloads, it risks falling into a Tier 4 capability trap. If those offshore connections are severed by geopolitical disruption or corporate policy shifts, the local infrastructure shuts down. The state cannot rebuild that capacity domestically in time to prevent a total service failure. Renting intelligence from external giants introduces structural risks. It exposes a nation to foreign jurisdictional control, embeds the biases of external algorithms into public systems, and makes national security dependent on the resilience of a foreign supply chain. Localizing hardware by placing servers in domestic data centers does not solve the underlying issue. Autonomy remains impossible if the software stacks and AI models running on those servers remain opaque or controlled by a third-party vendor. Historically, digital sovereignty was treated as a legal concern, addressed through localization mandates and contracts. A sovereign-by-design approach moves this requirement into the engineering phase, making autonomy a core property of the system architecture. This strategy organizes national infrastructure into a layered reference model. At the base, identity and trust are anchored in a blockchain. Above that, sovereign data governance dictates how information is stored, followed by the AI lifecycle, and finally, the public applications. Integrating these layers creates a framework where a nation's legal system is woven into its technical foundation, ensuring that its digital assets remain under its own control and are governed strictly by its own laws. The Kingdom of Bhutan provides a real-world model for this foundation. They have implemented a national digital identity system that removes the need for centralized government databases. This relies on self-sovereign identity, a framework where a citizen stores their credentials in a secure digital wallet on their own device. When they access a service, they share only the specific proof required, while the service provider verifies it without ever contacting a central registry. To ensure system integrity, Bhutan commits cryptographic proofs to the Ethereum blockchain. The actual personal data is never stored on the public ledger. It remains encrypted and local to the citizen, pairing global uptime with strict local privacy. In Europe, this new legislative push for tech sovereignty utilizes public procurement. By favoring technologies made within the continent, the EU aims to build a resilient AI ecosystem that is not dependent on unilateral shifts in foreign policy. Estonia secures its data exchange through a federated network called X-Road. To guarantee the auditability of these flows, they use keyless signature infrastructure. Irreversible hash values are submitted to a network to verify the time and provenance of a record, ensuring that no one, including the state itself, can manipulate digital records undetected. By decentralizing identity and data exchange, nations eliminate the central honeypot vulnerability, building a foundation where trust is guaranteed by cryptography rather than centralized authority. Physical infrastructure remains the ultimate constraint. In Japan, SoftBank is launching a sovereign neocloud, ensuring that the localized GPU hardware required for AI training and inference remains governed by domestic law. These specialized AI factories require massive capital to deploy rack-scale GPU clusters. They use advanced interconnects and data processing units to manage the intense throughput required to train large language models at a national scale. However, even localized hardware has a vulnerability. While data is typically encrypted when stored or transmitted, it must be unencrypted in the system memory during actual processing, exposing it to potential hypervisor or operating system breaches. Confidential computing addresses this by using hardware-based trusted execution environments. These processors create a cryptographic boundary that isolates sensitive data from the rest of the chip, ensuring that information remains protected even while it is in active use. This isolation now extends to entire GPU clusters. It ensures that proprietary model weights and sensitive citizen prompts are never exposed during the computation, providing end-to-end control at the silicon level. India's Bashini infrastructure demonstrates how this stack works at a population scale. It allows a farmer to record a voice note in a local dialect and receive an accurate response from the state regarding agricultural benefits, bridging a profound linguistic divide. These services are built using AI blocks, modular, swappable functions for tasks like transmission or document verification. This modularity allows a nation to independently evolve its intelligence, swapping one model for another without needing to rebuild the entire public service pipeline. To verify that these models are unbiased without exposing private data, nations are turning to zero-knowledge machine learning. This protocol allows an AI to process local data and generate a mathematical proof that the calculation was executed faithfully without revealing the sensitive inputs used. Standardizing how these AI models connect to secure data sources is now handled by the Model Context Protocol. It provides a universal interface that allows an agent to read databases and execute code across disparate government systems without custom coding. To ensure accountability, the Know Your Agent extension adds cryptographically verifiable identities to these digital agents. Every action taken on the network is signed and auditable, ensuring that the entire chain of actions can be traced back to a human principle. Nations like Papua New Guinea are using these strategies to move from renting to owning their digital tech stack. By focusing on sovereign cloud hosting and data governance, they are protecting their national narratives from being misrepresented by external algorithms. Achieving this requires a systemic change in how governments acquire technology. Instead of signing monolithic contracts with single foreign vendors, states must focus on acquiring modular architectural building blocks that they can independently maintain and modify. This transition secures the digital future of a nation. By anchoring every layer of the infrastructure in verifiable architectural constraints, the state ensures that its most critical assets remain within its own jurisdiction. A nation's independence now relies on its ability to independently modify its digital systems and audit its data flows. It ensures that as artificial intelligence increasingly manages the mechanics of society, the defining rules and oversight of that intelligence remain firmly and transparently under public control.